This is the second in my series of videos about planning and building a CNC router. I finally bought some stuff. I decided to build this based on C-beam V-slot in the end. I bought a lot of stuff from a company called Nest in the UK who supply V-slot stuff, kind of mechanical, electrical, lots of stuff to do with CNC router. However, there's a few components from Nest which to me seem like I could probably get them cheaper elsewhere. Nest are really good with delivery. I've been impressed with how quickly everything's arrived, but there's a few little components that I'm probably going to be waiting several weeks for to get direct from China. But what I do have today is my electronics. I've already got the motors, which I've had for several years actually, and probably today all I'm going to get done is actually connect the electronics up to the motors and the end stops, make sure it's all working. So everything that turned out to be from Nest in the end. They sent me a Taurino power with a nice long USB cable in. They also sent me that USB cable, which I'm not really going to need. That's probably just because I bought the RAMPS board as well. That's just a standard ramps, and these are my DRV 885s. I bought 5 of those in the end. I'm going to use 4 of them only, but I just decided to buy 5 just in case I fry them, as I usually do. At least I have fried a few of the standard motor drivers before. I'm going to use 4 because I decided to get the maximum amount of torque out of the machine instead of just driving the Y-axis using 2 stepper motors connected to 1 driver chip. I'm just going to give them 1 driver chip each. It's hardly any more expensive, and be interesting to see if that makes a difference to the torque. I bought a standard rep wrap wiring kit with 1 meter long wires in it, and also I dug out these Nema 23 motors that I bought years ago, which I added a lead onto, but I'm probably going to rewire these today with 1 meter leads anyway, just to make sure that it's long enough. And a whole pot of the original rep wrap end stops, opto end stops, which I never used, which should still be compatible with the ramps board, etc. But also, probably going to rewire these with the wiring kit as well. It's also nice to see the DRV 88s are supplied pre-soldered, because I have made a mess of soldering up the other driver chips. For some reason, I count myself as a pretty good solderer, but for some reason as soon as I tried to solder one of these on, I managed to mess it up. So I'm just about to rewire all the motors with the standard rep wrap wire, meter long. It's useful at least because it has the motor plug on, which is compatible with ramps. The wire is a bit thinner than the really heavyweight wire that I wired the motor up with last time, but I reckon that's not going to make a difference because the wire leading to the motor itself is not that heavyweight. One silly thing that I've done is not actually bought heat shrink, which is the right size for the soldering that I'm about to do, but I managed to find this quite large stuff, so probably what I'm going to have to do is wrap each joint in electrical tape and then put the heat shrink over, but at least that's going to keep the wires together and it should be fine. What I might try to do is finally verify if I wired the motor up correctly last time, because most stepper motors come with more than 4 wires leading from them, and what you have to do is work out which are the center core wires and which are the, I can't even remember exactly what you have to do, but basically you can control them with 4 if you wire the other 4 to each other, or that is in 2 pairs. And maybe this is a good time to just check that I've done that correctly. So I just refreshed myself with some facts about stepper motors. What I was talking about was that what I meant to say earlier on was that this is actually a unipolar stepper motor. At least it's wired in a unipolar fashion, and the driver chips on RepRap and a lot of other driver electronics are bipolar. That is to say that they only they treat the stepper motor as if it has only 2 coils, whereas this one has 4 and 8 wires coming out of it. I just did some, as I said, refreshed myself about it, and it turns out that 8 wire steppers, as you might think, are the hardest ones to try to work out what the correct wiring should be, because there's so many different combinations. But luckily it still has its serial number attached. But I googled the serial number and I got a good data sheet with some almost accurate color coding on it. It turns out that all the wires with white stripe on them are the end of the coil that I need to wire to, basically. Essentially this has a white stripe on, that has a white stripe, that has a white stripe, and that has a white stripe. So, and the solid wires are the inner wires from each coil. I'm not making this clear at all. Essentially what you want to do is wire those 2 middle ones together and those 2 middle ones together. So you're essentially wiring each pair of coils together in the center, and then treat that pair of coils as a single coil. And all those central wires are solid. So as you can see, what I did is I just soldered the 2 pairs of solid wires together and heat shrinked it and just tidied them up. So I'm just tinning the ends of each of the stepper wires. The ends of the RepRap wiring kit are already tinned. That's what I like about using these wiring kits. It's just so much, it saves a lot of those little jobs. So before I solder them all together, I'm going to make sure I remember to put on a good length of heat shrink onto one of the sides of the wires. Just going to gather all of the wires up together. So it didn't really matter exactly which wire I soldered to which at this point, but since I happen to have RepRap wiring kit with red, green, blue and black, I decided to solder them to the red, green, blue and black from the motor, just to make things easier to diagnose if anything goes wrong later on. Now those are cooled down from the soldering, I'm going to wrap each joint in electrical tape, then push over the heat shrink and shrink that on. As I said, I should really be heat shrinking each individual one as well, but I didn't have small enough heat shrink at the moment. So I wrapped each of the joints in tape. I'm just going to shrink wrap them all together just to keep that tape on, which is better than nothing, I think. And again, I should probably be using a hot air gun to do this, but I find that a soldering iron also works for heat shrink, as long as you don't keep it on so long that it burns the heat shrink, obviously. So I've also got these smaller motors which I bought to build in an attempt to build a rep strap machine that I never quite got round to. But I figured I can use one of these for the Z-axis, use 2 of the larger ones like that for the Y-axis, and a single one of these for the Z. The wiring on that one turned out to be slightly different. There's a yellow wire in there instead, and on this one I also managed to find the data sheet for this one online. The solid coloured wires are the ends of the coil, and the white striped ones are the middle, and the yellow one is just in the place of where the blue one was on the other. It seems to be there's a common theme running through stepper wiring. There don't seem to be too many differences between them. So these are the RepRap version 1 end stops from a long time ago now. I probably bought those in about 2007 and assembled them. I just put the new style rep wrap wiring on. Well, I was certain that I had a proper dedicated power supply. Well, that is one of these purpose-built PSUs. I kind of, as you've gathered, I tend to buy weird stuff over the years, but turns out this is 36 volts, so it's not really suitable even for Taurino power, and probably not for the stepper motors either. Luckily I've got an old ATX power supply that I could at least use to get the machine running. If it looks like it's running out of current, then that is, if it looks like the current's not enough, I can always replace it with a proper PSU. But here it says at 12 volts it can supply 15 amps of current, so you know, that sounds like enough. I've also got an Apple power cable, which I don't know, I kind of found that amusing. Now, I'd actually scavenged the ATX plug off this for something. I can't remember exactly why now. Obviously it's not safe to turn the power supply on in this state, because there's a lot of current potentially being supplied through these wires, and they could just touch plus to minus, short circuit, and probably destroy the whole thing. So I've got to make sure that I just gather the 12 volts and the ground, and probably just cut the rest of these back and protect them somehow, maybe heat shrink them in, or just electrical tape for now. The thing to remember about ATX is that there's this green wire here which must be connected to ground, that is the black ones, in order to power on the power supply. Here's the ramps board. Because it draws so much current, you'll need to plug two 12 volt wires and two ground wires into there. The 12 volt wires on ATX are yellow, so what I'm probably going to do is take these couple to the ramps and a couple of these ground wires, and cut the rest of the metal connectors off, just so there can be no metal to metal contact between any of these wires. So I got the ATX power supply wired up to the ramps plug here. Got the green wire going into one of the ground connections, just to make it power on. I've powered the power supply on. I'm just going to check that the correct voltage is coming through, because I don't want to destroy anything valuable. You can see I've got almost 12 volts coming through on each pair of ground and 12 volt wires. So there's the Taurino. I'm just going to fit the ramps board to the top. Okay, those are together now, but as with a lot of these ramps boards, it seems like this power plug is actually preventing the ramps from sitting correctly. And on the last, on the laser cutter that I transferred over to ramps, I just kind of let that go. I didn't think that would be too much of a problem to have a slight gap in some of the headers, but it actually interfered with the end stops, and it gave me a whole load of trouble. So I think the best thing to do is get that plug off before I do anything else. Now, I'm tempted to try to desolder that plug, because it seems quite violent to, or potentially damaging to try to just cut it off, but I think that soldering on a board with all these surface mount components is not a good idea, because they might start to fall off. So the old cutters seem to be the best move. Okay, that was pretty easy. Most of the it mainly just snapped into little pieces and came off. There's no danger of any of those contacts touching together. I just totally cleanly cut the connections off from that plug. So that went together pretty perfectly now. There's no gap showing on that side near to the plug at all. And of course you don't need the plug, because this is where the power is supplied. So before I even connect any stepper drivers or anything that doesn't strictly need to be on there, I'm just going to make sure that the board powers up. I'm just going to plug that in, turn on the power supply, and just see that the Arduino lights up. So the ATX power supply is on now, and there's a happy little orange light from in there. Just leave the Taurino and ramps here on the bench, and then plug it into my laptop. So I just downloaded the latest version of Marlin from GitHub. I was just looking through the configuration options, and I noticed they actually have a dual Y stepper drivers option now, which is pretty useful. I thought I may have to do a little modification to get that feature, but it looks like if I can just uncomment that line, save it and flash it on, that should all be enabled. It's called Taurino, the board I have, but I need to select Arduino Mega 2560, hit upload. So it seemed to go on okay, but before I do anything else, I'm just going to make sure it's okay by loading up Pronterface, click connect. I got a reply in the Pronterface console. It does say temperature error, so the firmware is not happy that obviously I have no thermistors connected, because this is going to be a CNC router. It seems like in this version of Marlin, 0 is an acceptable setting for all the temperature sensors. So I set them to 0, flashed the Taurino board, and print run connected, and it's showing. So now I think it's time to connect some motors and see them move. So since I've never used these DRV8825 boards before, I just googled it and got some advice from the RepRap website. The main thing is, it seems that the orientation, at least relative to this pot, is the opposite way around to what it would be with the other stepper drivers. And also it says it's wise to turn the trim pot down before you even connect it to a motor. So that should be the correct way around. The trim pot facing where the USB cable is. So I'm going to turn the big power on now and just check for smoke before I go any further. Well, that seems okay, so I think it's time to try plugging a motor in. So that's plugged into what will be the X-axis. I'm just going to try issuing a move command on Pronterface and see what happens. The motor's not moving correctly yet, so it's just kind of jumping around. It's worth pointing out something that I noticed when I was trying to set up the motors just now. I just couldn't get them to turn smoothly, or in fact at all, in any recognizable direction. They were just jerking around. It didn't seem to matter how I set the wires up either. Well, the method that I was using, this is not part of the problem, by the way, this is the right way to do it. It's a really good tip from the stepper wiring section of the RepRap website for an unknown stepper motor trial and error wiring method. The idea is that you just plug it in, see if it works, see if it turns. If it doesn't turn, you switch the end pair of wires over within the plug. If it still doesn't turn, you switch the middle pair of wires over in the plug. So that means you'd only have to do 3 steps and it would work. So that sounds really simple, but the problem being that the speed setting here was set to 1000 millimeters per minute. That seems quite reasonable. You'd think, you know, there must be a problem if the motor is not turning at a meter a minute. But of course, the unknown here, which I forgot about, was that the Marlin firmware has just some random steps per millimeter setting. So it could be, in effect, it could be asking the motor to turn way too fast, which was actually the case. So as soon as I realized that could have been a problem, I reduced the XY millimeter per minute to about 50, which is obviously really slow, but I just wanted to eliminate any possible effect that could be happening. It turns out within about 5 minutes I'd actually worked out the correct wiring for 2 of my motors. So I'd managed to find the correct order for the wires on all the motors. I only had 2 types, the kind of larger Nema 23 and the shorter one. So I've just rewired all the plugs to be the correct order. And now I'm going to set the correct steps per millimeter. I always use this calculator on prusaprinters.org. I'm planning to use M8 lead screw, and that's such a common setting that it's actually the preset on the calculator. So that should be, for a 1.8 degree stepper, 2,560 steps per millimeter. I'm just going to set all of those, including the extruder steps, to 2,560. I'm not obviously using an extruder, but it's easier to just tell the software that I am, so that I don't have to go and modify everything. So I'm making mistakes about pretty much everything for some reason at the moment. I forgot to add these things onto each of the axis jumpers. These calibrate the micro steps. That is to say, these set the micro steps for the stepper controllers, and they just fit underneath each controller board. These are specific to whichever stepper controller you're using, but with mine, the DRV8825s, I decided to try the maximum resolution now, as I remembered to find out about this. There's a table here which I found on pololu.com. So here it says either low or high in each column on each row. If it says high, it means you put a jumper. If it says low, it means leave the jumper off. If you put a jumper on each one of the connections beneath the stepper driver, it sets it to 132 stepping. Probably that level of accuracy isn't necessary, but I just decided to give it a go. I put that back into the Prusa calculator. It's kind of weird, it says 1/64 stepping on this option that I selected. It actually means 1/32. But predictably enough, the result is twice what I first calculated, 5,120. So I just set that on all the axes. And now the motor is turning okay. If I just and just through trial and error, I found that about the maximum feed rate I can get up to is 100 millimeters per minute. I think that's probably to be expected with a lead screw driven system. The reason people use belt is obviously there's no reduction, and it means the stepper motor doesn't have to take the pulses so quickly. Having said that, that may be something to do with the reason people choose a lower resolution on their steppers, because the pulse rate would be lower. So I made a few more changes to the configuration on Marlin. I found that the dual Y axis drivers were set up to invert one of the directions, so I set that to false, so they now turn the same direction because they'll be using threaded rod. They don't need to be inverted. I also, the Z axis motor actually has 0.9 degrees per step instead of 1.8, so that needed to be set to, again, twice 5,000 and something. So I changed that, and now all my motors are running smoothly. I had to set the default feed rate to 100, but we'll see. I may just disable micro stepping if I get the printer running, and it's actually, that is to say, if I get the router running and the speed is too low, I think I can increase the speed by removing micro stepping. The two Y motors, I worked out that the second Y axis is running off what would have been the second extruder, which is marked E1 on the ramps. So you can see all of them running. So if I tell Y axis to move, both of the Y motors move in the same direction. X is turning and Z moves. Next step now is to get the end stops connected. So I've just connected a single one of these old RepRap version 1 end stops to the ramps board, connected to the board in fronterface, and I'm using the M119 command, which tells you all of the end stop statuses. And interestingly enough, it reports triggered for the one that I've connected. And then when I place a bit of tin foil, you can also use cardboard. So when I place the tin foil in the end stop and click and send M119, it says it's open. When I send M119 without it, it says triggered. So that tells me I need to reverse the end stop status. It seems like the default in the Marlin config is to invert all of the end stops. So just in the configuration file, I'm going to set all of the end stop inverting to false. So this is a proper shot of what it looks like when you're testing end stops. I've written M119 in the console here. I'm just going to send that. So now it says all of them are open. Because they're sent to not invert, it means if you don't have an end stop connected, it will say it's been triggered. I'm just going to take my bit of tin foil and place it in one at random, and then when I send the M119 again, it shows that it's triggered, and the one I put it in is Y max. And if I go to Y minimum, it shows triggered. That means I'm actually going to be able to do a small test to make sure that the minimum end stops are actually going to home it, allow the axis to home and stop it damaging itself when it's all installed. So if I press the Y home button, you can hear the motor have started. I trigger the end stop once, take it out, trigger it again, and now the motors have stopped. So that tells me it's running correctly. The reason it does it twice is because the first time it goes through the end stops, that's kind of that's a coarse stop. So it will then draw the flag, obviously not aluminium foil, out of the end stop, and then push the flag back in again slowly, and that's the second trigger, which stops the motors. It was a fairly productive couple of hours. I've got the brain and the muscles, if you like, of the machine all working. I've verified that a few of these aging parts here and version 1 RepRap parts are still working pretty well. I'm basically now waiting for a few of the parts that I ordered from China to arrive, some of them which are to do with my C-beam linear actuators. Probably in the next blog I'll have a bit more to show you about how I'm planning to custom make a few parts of these actuators to try to bring the cost down. So obviously that may not work, but then in that case I haven't really lost anything. I've at least given it a go, and I can always buy the correct aluminium parts later. It'll just be interesting to see if I can make acrylic parts which are strong enough to at least cut a bit of aluminium out, so the machine can then build parts of itself. So yeah, if you found this video interesting, there's already a video on this channel about how I converted a laser cutter from China to run on G-codes, as well as a few other laser cutter related projects. This channel is going to accumulate a lot of stuff to do with any sort of open source electronics or making in general. So if you like this, please like the video, subscribe for more, and goodbye.